Feel welcome.
Thank you so much for your generous introduction, and I would like to thank all of you because of this invitation. And I can see lots of faces. I'm a very much, a big fan of Spanish language and Latin American folks. Thank you so much for having me. Right now, already Dennis has introduced some of the works I've been doing, and mostly those are about the organizations. But I would like to call myself just an educator and a learner, nothing more than that. And today I'm really lucky to have you all here and talking in front of you. And let's see, I'm gonna take you to the presentation. Is there the time to take all of them to the presentation right now, Dennis? Okay, cool, great. So quite buenas a todos. Gracias, everyone. So let me, pardon my Spanish. I'm just learning, so I'm sharing my screen. So can you all see my screen?
Yes. Yes.
Great. So yeah, already you all know that the title is Enabling Technologies and Skill-Based, well, STEM, we all know about STEM, science, technology, engineering, and maths. Now arts is everywhere, right? So we have been talking about arts integrated with our life and science. So I just put that here. So now, this underprivileged class communities, as we are from a country or the part of that third world where underprivileged children, they are the major percentage in our country. So mostly if we want to educate a certain percentage of the whole generation, we really have a big chunk of them. So I started that. But let me tell you a story why I started this. Before making this an education platform, I was actually working on my lab, mostly on biotechnology, biology, but it was a time when I saw someone lost his hand, an orphan lost his hand, and I looked for it. He was the only earning child, and he had to take care of his brother and sisters, little brother and sister. So I was looking for, okay, maybe there's something we can do about it, because there were no functional prosthetics. All the prosthetics we could have here, they were wooden and non-functional. There's no point of using that if you can just show it off. Then I was looking for it, how much functional prosthetic can cost. So it was pretty expensive, even in MIT and many of the universities. Recently, there are many cheap versions, but that time it was really expensive. It starts from $5,000, but we cannot afford that. So that's why we started a tech company, MECHAMIND, and we did it under $100, 100 USD, a fully functional prosthetics. So maybe I will be able to show you a video somewhere in this lecture. But however, so after that, we kept working on that, making many versions. So that's how we started a couple of years back. So I was I was a student back then, and yeah. And after that, we got to know there are many people who are underprivileged. They don't have many facilities, and if we want to have a generation which is going to help us to build this country, maybe we need to educate them, and we cannot do without teaching underprivileged science education. So yeah, that's how we tried to incorporate education on that, and that's how we started. MECHAMIND is situated in Bangladesh, a country, a very small country in Asia. And I live in Dhaka. I'm Salman Promon. So you already saw my name. And let's not waste time on that. So here we are. So we are dedicated to develop open community, and we're trying to collaborate with different like-minded people, communities all around the world. For example, right now I'm having a conversation with you guys, and I'm sure many of you have been working on many of the projects like that. And so we are very open. We are trying to put together all the expertise, all the directions we can have, all the learnings we can have from different communities all around the world and local, so that we can translate and transfer those knowledge, or at least those strategies for our purpose, which is enabling these underprivileged communities. And also, not only that, there are other communities who could be beneficial from them. So our works actually includes engineering, biology, design, charity, and also all of those for a purpose that is economic empowerment. So as you can see, some of the, here we started this DIY biology equipment production. This is 3D printing arm, and also enabling techs like skill-based personalized education for socio-economical benefits. Think about it. I am actually coming to that, what kind of skill-based education, but we're trying to, since we have been mentioning a couple of times that we're trying to enable a generation. So we're trying to provide those skills so that they can be able to use them for their, not only their empowerment, not only their own development, but also the society around, because science, technology, those are kind of enabling them to get into industry-based, employment, and those employment will be able to make them more capable of, contribute to not only their life but also the country as well. So, well, this is a very far-stretched talk, but then we have also included community biology. So we started teaching them biohacking, through biohacking actually, because as you can see, this we go to different slum schools, and we are thinking biology, biotechnology is the future. And recently, this COVID actually taught us very well. So biotech-based employment to solve real-life problems, and also we all know that biotech can actually help in healthcare, food, environment, and other industries, as well as economical, industry-based sectors. So this is the things we are doing. But let's see. So this is the version 1 arms we were talking about. This is the functional prosthetics. Version 1 arms we were talking about. This is the functional prosthetics. Actually, not only this, we are trying to educate them with biotech innovations and integrated sciences. So biology, engineering, maths, arts, these things together, and empowering those physically and mentally impaired communities. Like I said, I started with that. We started with physically impaired person. So there are more than 8,000 children in our country. They somehow lost their limbs, mostly upper limbs, legs or hand, and maybe eyes. So we are working on these technologies, like making devices, for example, prosthetic hands, wheelchairs, artificial intelligence-based assistive system for the autism or neurodiverse people. And we're doing it in very, those are already in the market, but those are like very expensive, but we're doing it in a very cheap process. We're sourcing them from the local stores, or we are producing them here. And also community biology education for future-proof open biosociety. Well, as you can see, the industry, from biomaterials, from vaccines, from food, from agriculture, so many things, those are directly linked to our life, and somehow those are connected to biology. So we believe that there is a huge industries going on or coming soon. So yeah, if we can create this skill-based education, this manpower, maybe they can be a part of it. They can be, put their labor on that, and that could be a very good earning source. So also, how we are doing it, we're trying to create the citizen science network of STEM with skill-based education and create this open science community, making science open for all, so that they understand the importance of, life, science, and business together. As you can see, we can see this situation in COVID, SARS-CoV-2. People are not wearing masks and they're refusing it. They're not having the healthy practices. So what do you think? If I give you the example, after teaching my students, I mean, in slum areas, they're like fourth graders, fifth graders, like seventh graders, very young, 6, 7, 8, 9, 10, 12 years old. And now, during this COVID pandemic, they were one of the first responders. They started using these healthy techniques, and also they were teaching their parents and all other people because they had this education on biology. They knew what is microorganism, what is the significance of it, antibiotic resistance and everything. So it's not like you have to educate them in their undergrad. You can start it from very early stage. Children, kids, those communities, they are very smart, and not only the privileged class, underprivileged class, they understand things if you can teach them or if you can provide them, because they are keen to learn. So as you can see, we're teaching them various things from architecture. Here, we are trying to teach them architecture, 3D printed robotics, biology, microbiology. So this team-based platform to integrate specific community so that they can go from idea to product in a comparatively lower cost. See, what we're doing, we taught them how to design 3D printed arms and how to assemble them. And after only one class, they were able to assemble it within 5 minutes, this thing. So this is amazing. I mean, like, they can do it. Those underprivileged, they can design it. They can create that that device, and they can earn money from that. And we can use these devices for, helping those communities physically impaired or mentally impaired, and they're learning microbiology or biological techniques, and they will be well aware of this kind of situation like pandemics and also vaccinology, antibiotic resistance. This kind of concerns. And not only that, this is the basic steps to know biology and get them into this, our desired path of skill, manpower development. And since we are growing as a community, the population is increasing here. So we cannot just build houses everywhere. I mean, this is a problem in our country. I'm not sure how you can follow that, but eco-friendly and green architecture is very important right now, because the way we are constructing is polluting the environment, and the way we are using so much materials, minerals, and the way we're design should be environment friendly and green, so that this can sustain and this can take less places. So architecture is very important. Construction engineering is very important, at least as a sense. People need to grow sense. And this community, underprivileged community, since they are 60 to 70% of our whole population, these kids will grow up and they will understand when they're putting their efforts, on that. So for this, we created this program. Actually, we have so many other programs like R&D, but I can show this one here. One project was 3D printed prosthetics. This group will be assigned to train and build a 3D printed functional prosthetic arm. So we'll be providing the materials here. This is the duration. And the second project was construction and design. The idea of building eco-friendly constructions, basic architecture, design, torch, and miniature models will be trained to build. They will design the model. They will talk about the problems, how it can, affect the environment or in the future. you have to make it in future-proof situation. And so they will actually not only design it, they will create a model. And also biohacking and DIY biology. They will isolate microorganisms from environment, use them to produce industrial product like biofuel. For example, we taught them how to use yeast and ferment and create and distill ethanol, bioethanol. And also not only that, we try to do some kind of DIY, extraction of certain gene and put that in and transform cell with that, and a very mimicry of transformation and recombinant DNA. So, and also CRISPR. So there are like many examples I can put, but the thing is with biohacking and DIY biology, and also we train them how to create some of the equipment so that they can understand. Just think, if you are just doing an experiment like electrophoresis or something, you'll know how it's working. But if you can build the device, you will know how you are putting the charges, how this negatively charged DNA will run into the positive one because of that phosphate bond. Sorry about it, I'm like putting into too much technical terms, but still, as you understand, if you put this engineering and biology together and you build a device, you will know. Because to build a device, you have to know the purpose. You have to know how this biological material will be, interacting with that. So that's why we not only training them in biology, but also building the device so that we can also source them locally. We don't have to buy it because there is no way we can purchase that expensive material from the market or from, because we're not getting it here. We have to import it from somewhere like United States or something, right? So yeah, I mean, also we train them in bioinformatics because we always can't provide them with wet lab stuff. So bioinformatics and synthetic biology is a very important one. So just giving them a touch because they're like playing with that. They're creating, constructing biorender, they're creating biobricks, they're creating, synthetic materials like primers, and also joining things. And also we're playing with Lego sets to teach them recombinant DNA technology. So this is amazing. I mean, like these children, they're like really amazing, and I really enjoy to spend time with them. I'm really sorry to my undergrad students. I really love more to spend time in slum schools, like elementary schools, more than my university classes. But I like to apologize. However, there's a device there. This is electrophoresis just right under $1. It's kind of like you can create within $1 US, a lunchbox converted into electrophoresis. And we're creating this microscope, and we're actually watching. We can see the yeast. We isolated it from edible yeast, and we cultured it, and we saw under microscope. Just think about those children. They're developing this microscope. They're culturing microorganism and observing it, and they're using it for other purposes. Like recently, we're starting biomaterials and also bioprinting. So this is a crazy plan. I'm not sure if I can do that, but I'm trying to teach bioprinting. And animal cell is like very hard to construct and like work with, but we're trying to teach them with yeast cell, like eukaryotic cell, and like different other materials we can source out from grocery shops. However, as you can see, these food colors are here. So this is a thing. I mean, they're learning the principles. They're creating it from their grocery materials, grocery shops under, $1 USD. So you can imagine how cheap it is and how they're finding love and passion when they're working on this, and they're actually doing very critical experiments. But this is fun. As you can see, you can actually teach them well, and actually they can do so many things, amazing stuff. So we also have our R&D. We're trying to not only the functional prosthetics, we are working on bioprinting recently. We try to do publication. We submitted a couple of publications, a couple of articles and papers. So this biohacking for kids education, we already talked about it, the STEAM education kit for middle schools. So now we're trying to create this kit for biohacking and STEM education so that we don't have to purchase all the time, because if you have this defined kit, this will be much easier to keep track and repurpose it for programs. Then we're also having this artificial intelligence power accessibility for disabled and paralyzed people, like autistic people or neurodiverse, cheap and portable diagnostic kit for infectious disease. We actually worked on SARS-CoV-2 detection device, and the NEB RT-LAMP, we validated it here. And I'm sure many of the people are working on that, even from our network. And also CRISPR-mediated SARS-CoV-2 detection device. And also, not only that, actually we started these programs before COVID. So we were working on some non-communicable disease detection because in village, people they don't usually go to the to doctor unless this is the terminal disease. So they actually eventually die, mostly for the terminal case of cancer. So we are working on circulatory DNA detection from the bloodstream. It's a very high ambitious process. We are working on our university laboratory and our specific laboratory dedicated, not community lab. It's a different part of our labs where we just do this kind of research. And also we are working on biodegradable packaging, and we managed to get some fund for many of the research here. Recently, for example, we started doing a kit you can detect rape specifically for rape victims, because many of the underprivileged class after this rape, I'm sorry, I'm talking about it right now, but it's very much biology stuff, because those underprivileged class after that, they sometimes cannot they can't get proper justice because they lose that specimen. Most of the time they can't prove it. So we are working on a very cheap and portable storage, specimen storage system, so that that victim can do it by herself or himself. Stores that's DNA. So this kind of community-based projects we are working on. So we are not saying we are doing so many high throughput experiments, but we are trying to keep it very root level and for people, with people. So this is our motto. So as you can see, we are dedicated to the open community and open science society, so that we can bring together, as you can see this picture, this is a slum kid, and she's wearing this hijab, coming from this conservative family, and slum kids, they can't even speak in English sometimes. Not even in proper Bengali. So they're poor, they don't have internet, they don't have anything, so they can't even have proper nutrition all the time. But they are going on, they are doing so many things which we can present in front of the world, and now they understand how to do streaking, how to do microbial culture, how to do molecular biology, how to do 3D printing and assembly within few minutes of their demonstration. Even I take class in my undergrad, even myself, when I first took that and I was streaking, I actually put that loop inside that, this media, and I cut that media in my first semester. But these guys, these people, they're only 8, 9, 10 years old. And I just showed them in the board, I drew how to do a streaking, and they just started doing it perfectly and without cutting the media. And they had this nag, they had this interest, they had this enthusiasm to learn it properly. So this is kind of untapped community. If we can teach them properly, these skills could be useful for not only them, but also for the whole country. So this citizen science, we're trying to create, connect, and collaborate. So public participation in scientific research for collective development. So we are trying to develop collectively so that everyone, can be involved. They can have this consciousness I mean, you know, if you grow this consciousness, you can actually have this vision, or you will have this understanding what to do or what not to do. So yeah, I mean, engagement of these citizens, good communication, contribute to the science, clear goals and reliable data. From all of them, we can actually we can look for creating the successful citizen science network. So other than that, I have another initiative, that is Star Labs Laboratories, Bangladesh, Science, Technologies, and Art Research Lab. We have this biology lab. We have this conference room here. We have this teaching assistive system. We have this electronics and mechatronics lab. We have this seminar room, classroom. People can take workshop over there. They can use all the teaching assistive system for webinars, seminars, for everything, even art exhibition. Actually, people can, the business, small business or small people, or they can't afford the office, they can use this office for monthly minimum charge. They can run classes, they can run workshops here. And also we also do run workshops and classes here. And you know, we sometimes, many of the workshops, they only have the class bed, but they don't have laboratory adjunct to that. So we have this facility, not only class, we also have laboratory with that. So that if you take a workshop on biology, for example, like CRISPR, you can just take after the class with these projectors and everything, like boards, you can take them to the lab and like teach them. So I try to create this whole environment where everything can possible, every learning can possible. Not only this, you can learn art, you can exhibit art, you can like have software, anything you want to teach or learn. So this is the lab, it's the first community lab in Bangladesh, so it's open for everyone. Independent researchers, innovators, they can come here, they can like public run classes and everything. So we are aiming for triple-E, empowerment, environment, and employment. So yeah, I mean, as you can see, I mean, why we're doing that? Because a third world country, right now, our economy, our remittance is coming from our government sector, billions of dollars and everything. So now, if we are thinking the shifting is going on, many of the things will be, you know, relocated to, the employment will go to other countries, other developing countries. So now, if we can create some of the sectors, if we create this, community who are they have this knowledge of bioprinting or this kind of like biology, so maybe we'll be able to create, you know, manpower. Maybe many of the in future industry, they will create industry in our country, so that there will be another, we can get orders, we can get, you know, we get to contribute to our economy by that. So I'm trying to make a generation fit for the next, you know, next generation job markets or industry. So yeah, I mean, another thing I want to say, like, it was really hard to bring those underprivileged under institutionalized education. I'm not talking about my initiatives. I mean, like before that, just regular education, just, you know, your national curriculum and everything. It's really hard because most of them are underprivileged. But this COVID, it actually backfired. This COVID actually took us back, and what we established right till now. Actually, this COVID, the underprivileged people, they can't afford devices. They can have the network, but privileged class, they can actually have the devices. They can continue their education. But underprivileged, they're most in percentage, most in numbers. And otherwise, if we can't educate them, if we can't keep them in track and institutionalize education, this generation will have a very hard time to be developed. So a country like us, we need them, we need the skills, we need to educate them. So this is a challenge. I would like to, ask all of you, if you have any idea, I would like to collaborate. I would like to know how to bring back these underprivileged kids to institutionalized education who dropped out of this pandemic. So these are the this is the project I'm currently trying to work on, and this is another, one of my projects. I'm working with some a supermind design. It's another course I'm doing somewhere. So yeah, I mean, I would like to collaborate. I would like to have your direction and your suggestion on that. How can we do that? Having the restriction and having those all the constraints due to the lack of, uh, resources and of course budget, because a country like us, we cannot provide devices and network for all of them, because we are highly populated country. It's like more than 180 million people, and we are only 50,000, more like 40,000 square kilometer bigger than Guatemala. That's it. But we're having, I mean, almost 200 million people. I'm not sure about that right now because the consensus is going maybe after a couple of months, maybe 180 million. So this is really hard time if we cannot bring back here. So yeah, our children, they are our future. Since our underprivileged class is like 70% of the whole generation of children. So I think this is high time we can work on them and enable them to be something so that they can contribute and create their life in a way so that this whole collective development can kick in, and they can contribute their economy and also the country. So yes, I mean, thank you so much for giving me this time and this platform. I would like to stop sharing my screen because I think this is the end of this presentation. Now I would like to discuss more if you have any question, and also, as I said, I would like to have your opinion on this particular project. So, muchas gracias, everyone.
Thank you, Salman. Right now, we're gonna start asking you a couple of questions. And Anna Fortuny asks, is it possible to design these experiments via online during the lockdown when we cannot interact in labs? Can you give us some tips?
Well, if you want to think, for example, we took this initiative during, I just can give an example. I have another company named X Genomics. So many of the this kind of trainings, which could be conducted online, those were really expensive. Even in even in many places, even in our countries, those were really expensive. And due to the COVID situation, many of the students, learners, their family income went down. They couldn't provide for their education. And this kind of trainings, those were nearly impossible. So what we did, we actually made that open for everyone. No registration fee, those were like totally free. And all you need a computer, or even if you cannot have this computer, we have this social distance center where there will be like a large screen and people will go different places. I mean, like from different places, they would take it. And we made those all contents free so that those devices, what kind of, we tried to get some, incentive from the government, some sponsors, so that they can have free data. So we made it free, and not only for Bangladesh, actually, people from 50 countries, they actually, came and like they went to our network, and many of the people from Canada, like Western countries, they came together, and I mean, like they stepped in front to teach. So this can be an option, open access. But if you want to talk about the physical stuffs, for example, like molecular biology or microbial culture, this is a very tricky one. If they don't do it by their hand, you can send some equipment. I mean, not equipment, I mean like instruction. How can they make their equipment at home? But again, if there's a country with low population, that's all right. But if you're thinking like countries like India, like Bangladesh, is very hard because you cannot provide all of these materials all the time. So,
Yeah.
it's always about data. If you are thinking about online, it's always all about data, your good network connection, have a device so that they can learn. This is the primary because everywhere this is going on. So, yeah.
Thank you very much. Next question, Anna Isabel. She asked, first she expressed, it is actually amazing that such young kids are doing such advanced things. If you start thinking on that, it is really an amazing way to form young scientists that are going to be interested in innovation and create, right? So she asked, how can we collaborate in your project then?
Well, thank you so much for your interest, actually. So right now, uh, for like if we talk about distance learning or distance education, at this situation, I would be very much eager to have some opinion or your ideation on the topic I just asked help with, how we can bring back this underprivileged class into education again. So if you can, we have this collaboration so that we can have this idea generation. And number two, if we can have some suggestion from your point of view or your learnings so that we can create the curriculum, how we can implement them more effectively. For example, like create any game or create anything that's like available at home. Maybe they can learn genetic engineering using their home materials, for example, like kitchen stuffs. So if
Mm-hmm.
you can generate some kind of ideas like that, I'd like really appreciate that.
Okay, thank you for that. Um, the next question, Andrea Carabucci asked, how can you do this work with kids in rural locations where there is no conditions for limited resources? Um, and can you give us an example of that? Like now that you just mentioned that you can use, for example, things that are available at kitchen or tools or basic um, things that we have that we can get in home. How can you like give us an example using that?
Right. So I have mentioned that our education part and R&D part, I mean the research part is like totally different. We have a proper lab setup for R&D, and we have this education platform. I mean, I actually carry those things. Those are non-pathogenic or DIY stuffs. Farm areas, different, places, and in weekends. And I take some time from their own schools. Actually, I don't go to house. I collaborate with the slum schools. Those schools are government funded or NGO schools. They are having regular education. So I ask them if you can give 1 or 2 classes for me per week so that I can go and teach them. So that part is just to teach them, not like create stuffs or they doing actual research. But
Mm-hmm.
when they learn, then if I can pick some of them who actually learned, who actually have interest, then I recruit them and bring to my lab where actually they can do research. So I'm not saying that I go there and I do research in that environment.
Mm-hmm.
I teach them there and I do the research part in my lab.
Oh, well, that is like a good initiative from your part. Let me, um, I'm impressed. Still, you continue talking, and I'm continue getting impressed with you, since the way that you have been handling, and not only that, you start with kids. Also, you teach masters degrees to the university. I like the way that you like handle it. The other thing, and the question that I have is regarding the STEAM focus that you have been handled. For example, how do you manage and interact many areas like mathematics, engineering, arts? How uh, how this like start?
Right.
Mm-hmm.
So, well, thank you so much. As I said, like in my bio, I guess I said like I'm a science fiction lover,
Mm-hmm.
and I used to like watch science fiction from my childhood and like read comics and everything. So those things actually, I had this dream too. I saw many scientists there creating so many things. I mean, at that time I didn't know. I thought scientists, that means they can do everything. I mean, like they're creating stuffs. Now I understand actually there are different, I mean, places for science. There are many specializations. There are many sectors like biology, molecular biology, even and even engineering. They're actually separate. But I had this inspiration from them, and
Oh.
that's how I tried to learn. And I actually admitted myself in architecture in my university. Then I shifted my department to computer science. Then from computer science, I went to biotechnology. Then I did my another major in microbiology. Then I went to electrical engineering. So I like keep like shuffling my studies, and like I took jobs in different sectors, do interior design to architect. I mean like computers. I mean software development and anything like anywhere possible, like astrobiology, astronomy, design. So business. So I mean I try to collaborate and like I just go and like try to work with different community, try to get involved in different startups. So with that, I took that experience like in firsthand. I mean, it's not like institutionalized education. I like learned it from the people who are actually doing it. So I spent some time. That's how, because I believe as a teacher, if you are a teacher, I mean, I'm not quite there yet. I'm still a learner, but if you want to be a teacher,
Mm-hmm.
these things actually help me because I can connect so many things together. Their life, because altogether their lives. I mean, not like biology, not like engineering. Science is all about everything. You need to have
Yes.
maths and everything, right? So yeah, that's my inspiration.
Yes. Everything is interact. Okay.
Thank
I'm
you. I have a
wondering.
question. One,
Oh.
Salman, how old are you?
I asked
I
him the
will.
same.
I'll be 26 in this December.
And you
Yeah.
have been like accomplished a really amazing work in a project. And my second question is how you manage funding to make all this possible.
Right. So this is interesting. Actually, I somehow I managed to be part of Rotary Club. I mean, I'm a Rotarian. I'm not sure how they took me because minimum age is like 30, and you have to be a kind of like millionaire to be a part of that. But
And we
somehow,
have Rotary team here in Guatemala too, Rotary team, yeah.
yeah. I mean, not that Rotarector. I mean, the Rotary one. I mean, like the senior group. So they actually helped me a lot. I mean, those Rotary and they're like really rich and everything. They have like bigger network, and also my university professors, and not only on Bangladesh, many university professors and different science community. They actually fund me, and also I actually spent 60% or to 80% of my salaries from a university in these community projects.
Hmm.
And
Hmm.
another thing, and when I don't have money, I just look for international competitions where they actually give you prize money. So it's a very tricky one. So I manage, sometimes I manage to get like first or second prize. They actually give, those prize money I utilize for this kind of projects. So in last year, before that, I was the runner-up in the Geneva Challenge. I was the first in Asia and second in the world. And I think United States, Columbia University, they were the first. So this kind of competition. Recently, I got like Manchester a prize from Manchester University of Cambridge in this year. So they actually gave a couple of thousands pounds. So this is pretty generous for me. So yeah, when I'm out of money, I just go for international competitions. So yeah, right. I'm so silly about it. I'm so sorry.
No, no, it's a good way to get some funds. Like if there are organizations that they can afford that, then the only thing that you need to do is participate. There's nothing to lose.
Yeah, great. So I would like to thank everyone. I mean, like the concerned person actually, because recently we created this RT lamp device under $100, and um, also a ventilator, which is also in like couple $200 maybe. So and for that we actually got a national design prize for that. That was also monetary prize. So we fund those kind of devices with the prize money or the design money. So that's how we try to make it sustainable. But still, I mean, I haven't created any professional state for my earning source. That's why I created this X Genomics, where actually we provide genomic services like genome assembly, genome assembly service, and also diagnosis service like that. So those are paid. Maybe I can channel my funding from those business to this, a part of the
Um,
charity projects. So let's see how it can work.
I have
Thank
a
you.
question.
Yeah.
Um, um, like all of the workshops that you handle and everything is the homemade projects are all from your authority, or you like have any source where you like get an idea and just apply it according to your conditions?
Both actually. I mean, it depends on the situation, how you know, how the regulations, the policies are working, and the institutionalized coding, and also sometimes depending on the funding, you need to choose between the two you just said. Mostly the second one, but we can go back and forth.
Oh, okay, perfect. I'm wondering if anyone has any other question or any comment you want to make to Salman.
Yeah, I have another question. How big is your organizing team and logistics and everything to make all this project? Do you have students like professionals, or how many people are there?
Yeah, that's a very good question. Actually, I was going to say that. Well, in MECHAMIND, I am gonna put the website link here. Um, so there's a yeah. So here you can see uh, the team. But other than that, I'm involved in different community, like community of biotechnology, and something like 10 to 15 communities in our country and internationally. So actually, if I if I ask for help or teach or so any kind of things, there are thousands of people. They actually help me to do this kind of things. And also, if I want to talk about the technical stuffs, I was actually involved in many, like recently, one of our organization, I was like involved to that. We got the first, I mean, like we become the champion in first global challenge. Chile is second right now, maybe. So this year, among 174 countries, Bangladesh got first. Our children, they were like a champion of robotic. So they are experts in robotics. So in MechaMinds, we have electronic engineer, like biologists and everything, and also like our community of biotechnology, our network of biotechnology. So there are lots of things. So here, many students, they're coming from different backgrounds, engineering, arts, research, biology. So not only my employers, and also I have my research students. I take class in my university and different, not only my university, other universities. So whenever anything is needed, people are really helpful. Many of them actually, they don't take any money. They just do volunteer works to work in these projects. So yeah, I think say all of them. I don't have any particular team. Uh, the whole community is my team. And I'm also the part of that team. So my organizations and my initiatives, I don't own them. Everyone is the owner. So yeah.
Thank you. I think this is a powerful idea that it's not yours. It's like a community work. And I think everyone is invited to be this part of this community, just not like for your country, but for the global communication and to global health. So thank you very much. And I give you the words for Denise.
Okay. Well, it seems like nobody else has any other question. So I would like to thank everyone in here that has assist, participate, and um, get interested regarding this topic that it's very relevant, and it let us know and remarks how everything is connect. Everything when we talk regarding biotechnology, everything is connect and interact. Different areas, different people, and thank you, Salman, for showing us how to be that our age doesn't. It is not necessary to be older to be a scientist. You're very young and you have reflect and let us know how we can, as a scientist, like take in consideration time, do not lose our time, and to be very communicative and talk with everybody regarding our projects so we can get help and support from others. So thank you very much. And now this presentation is over. I just want to know everybody to continue to our next presentation. So that it's
Thank you
all.
so Thank you so much, everyone. So yeah, I want to finish with that I'm not a scientist yet, maybe a couple of years later. So thank you so much for having
You
me.
already are a scientist.
Yes.
Not yet, but yeah, thanks for this compliment. And I would like to thank all of you. I mean, and I would like to visit this Latin American community like very soon if this
Okay.
You are
pandemic is
more
over.
than invited. Just COVID let us, you are more than invited to come to Guatemala.
Great,
Yes.
thank you all. Thank you so much for this amazing event. Yeah,
Thank you, Salman. Talk to
Thank
you soon.
yeah. See you
thank you
all.
for
Bye bye.
sharing. Bye bye.
Of course. Bye.